Hello, welcome to a problem dealing with the slope of a line. So we have at the top of our screen all sorts of measurements. We see that there is 20 horizontal feet between this wall and this building. We see that the building is 50 feet tall, that the wall is 35 feet tall. We have at the beginning a man who is 6 feet tall, and we are asked how far north of the wall must the man stand in order to view the top of the building. And we have that down here as this question mark. So how far north must the man be in order to view the building? So the first question that we're asked in this whole scenario is, what is the slope of the man's sight line, which is the diagonal line in the picture? And we know a lot about slope, and we remember slope in different ways. So we think of M as the letter for slope, and I often think of it first off as rise over run as my easiest go-to memory. And the rise, I know, is the change in the y direction on the x-axis or on the coordinate plane, and the run is the change in the x direction. So when I'm thinking of those outside of the coordinate plane, this is my vertical versus my horizontal. And I know that a line, and since we're working with the diagonal line right here, has constant slope. So it has a constant rate of change, because we also consider slope to be the rate of change. So when I look through this picture over here, I have to come up with a place where I know a distinct horizontal change and a distinct vertical change, and I can use them together to figure out the slope. So right here, I know that if I start at the wall and I move over this direction to the building, that I have gone 20 feet. So that is the horizontal direction, 20 feet. What I want to figure out is in that same time frame, so if I would dot this straight across, and I know you can't really see that, but in that same time frame, how much vertical distance have I changed? And I should be able to figure that out because I know how tall the wall is and I know how tall the building is. So using those numbers, the building is 50 feet tall, the wall is 35 feet tall, then that would be a change of 15 feet. So I'm going to put those information together to have my slope. So my slope was a vertical change of 15 feet for a horizontal change of 20 feet. Now, I could reduce that fraction or make it a decimal or any of those good things, but truly I don't need to. I have the slope. Okay? So then it asks us to use slope to determine how far north of the wall he must stand in order to view the top of the building. And so this is where I have to bring in this idea that slope is going to remain constant. That ratio will not change. So 15 over 20 is my slope. And I am asked to figure out this horizontal distance, how far from the wall. And when I look up here about what I know about slope, horizontal distance is on the bottom. So what I'm really trying to figure out is what is the change in x. And that means I'm going to need a number here for the change in y. So I have to figure out from this wall to the person, how much has y changed? Well, I look at the height of the person, that's 6. I look at the height of the wall, that's 35. So if I do the subtraction, then I come up with a difference or a change of 29. So really what I'm asking here in my proportion is if the vertical distance changes by 29, in that same time frame, how much does the horizontal distance change? And so we can solve this using our cross product idea because we have two fractions that are equal. So we're going to multiply on the two diagonals here. And so we have 15 times the change in x, and that's equal to 20 times 29. And a calculator will obviously do that math for us. And then to figure out the change in x, we would just take this and divide by 15 on both sides. So 20 times 29 divided by 15. And I get the change in x is equal to, I'm really struggling with my pen, so sorry about that. Change in x is equal to 38.67. So that's an 8.67. And this is the change. Now, when I go back to my picture, that 38.67 does answer the question mark because we went from the man to the wall as our vertical change. So our answer, the change in x, is the horizontal change in that same time period. And so we have our answer to the question.